Transporting uranium waste. On-site burial is the safest and best option. For mine wastes, otherwise called tailings, it's best to put it back where you found it. And what are mine tailings anyway? Mostly finely ground up rock, basically. The milling process extracts the ore, in this case uranium, from the parent material. The leftover parent material needs to go somewhere, and the mine site engineer specially builds facilities to store this material. Essentially, these tailings facilities are specialized landfills. Material in the tailings is other minerals and some residues from the milling process. In Saskatchewan uranium mines, these other minerals can include trace amounts of nickel, manganese, arsenic, iron, and radium. Remember, the uranium has been removed because that's what they were mining. How radioactive are uranium mill tailings? It varies depending on the amount of radium and other uranium decay products. So what are the issues with uranium waste? Transportation. The shorter the distance the material needs to move, the safer it will be. Keeping materials on site eliminates the possibility of spills and incidents in transport and reduces possibility of exposure. Toxicity. The tailings material does contain contaminants that could cause issues in the environment, so they do need to be contained. Aesthetics. The tailings facilities are different than the surrounding landforms during operation, but are designed to fit the landforms once they are decommissioned. Future land use. Tailings facilities should be restricted from future incompatible land uses. In Saskatchewan, uranium mines are in the north, far from populated areas and relatively isolated. The other question is, where would these uranium wastes go other than on site where they were mined? We could imagine the issues with trying to select a suitable site that people in that area would accept. The main things that make on-site disposal the best and most effective option are the materials can be transported in pipelines over short distances, lowering the likelihood of transportation incidents. The materials can be dewatered over time on sites, helping to consolidate the material and greatly reduce the movement of material out of the tailings mass. If the material is placed in mined out pits, as is the current practice in all of the active uranium mines in Saskatchewan, there will not be any surface dams or dikes that will need to be maintained over time. For in-pit tailings facilities, this is how they work. First, a drain layer is placed at the bottom of a mined out pit. Tailings are placed over the drain layer so that water can be collected in the drain and pumped for treatment. As the water is drawn out of the tailings, the material consolidates and becomes increasingly impermeable, helping to contain contaminants. A water cover is kept over the material during operations for protection from radiation and freezing. Once tailings placement is complete, a soil cover is placed on top of the tailings, and in most cases, a water cover will be placed over this. After completion of operations and following the decommissioning process, you end up with landforms that look something like this.